In this video here, we're going to talk real quick about the local extrema and the x-intercepts of polynomial functions, or of the graphs of polynomial functions. Right? So a polynomial of degree n, remember the degree means the highest exponent that polynomial has. Right? So if I have a polynomial of degree n, it's going to have at most n minus 1 local extrema. Now local extrema means local minimum and maximum points. Right? So whatever my degree is, whatever my highest exponent is, I can have at most one less than that minimum and maximum points in my graph. Right? If you think about some of the graphs that you're already familiar with, the graph of a quadratic function in x to the second power, well, that's a parabola which only has one minimum point or one maximum point depending on which direction it's going, but one is one less than two. Right? And other graphs, like if I have an x to the third power, well, I can have at most two minimum and maximum points, and that graph would look like this: a maximum point and then a minimum point, and then it goes on its way. Right, so one less than the degree, that's the maximum number of local extreme points you can have. Now, you're not always going to have that number. That's the maximum you can have. But you could also have a cubic function, an x to the third power, that actually doesn't have any minimum or maximum points. Right, the basic graph of x to the third, which kind of curves like this and goes up, that graph actually doesn't have any maximums or minimums. It has zero local extreme points. Right, so again, you don't have to have n minus 1. That's just like the limit, the most you could possibly have. Right? And there's a similar thing for the x-intercepts of the graph. A polynomial of degree n has at most n x-intercepts. Right? So whatever that highest exponent that you have is, that's the maximum number of x-intercepts you could have. Right? So if you have a polynomial function that's an x to the fifth power, that graph could have 5 x-intercepts. And again, it doesn't have to have 5 of those, but 5 is the most that it could have. Right? It could have less than that as well. All right. So those are basic rules for the graphs of polynomial functions. So when you're graphing polynomials, and if you haven't seen the other videos that I've done about finding the zeros and the multiplicities of the zeros and the end behaviors of the polynomial graphs, you might want to check those out. And when you put them all together and you're actually graphing polynomials, these are just a couple things you can keep in mind to make sure that you're doing things correctly. If I have an x to the fourth power and I draw the graph, and that graph has 5 minimum and maximum points, I mess something up. Because if I have an x to the fourth power, it can only have up to 3 minimums and maximums. All right. Again, if I have a graph of an x to the fourth power, and that graph crosses the x-axis 7 times, I messed up because it can have at most 4 x-intercepts. All right. So it's just little things you can use to double check to make sure that you're doing the graph correctly and that it all kind of fits together. All right, and as an example, I'm going to use the calculator to draw the graph of this polynomial, just to show you what it looks like with an actual graph of a polynomial. All right, so we have p of x equals x to the fourth plus x to the third minus 16x squared minus 4x plus 48. And when you graph that polynomial, it looks something like that. Now, I played with the window to make it look nice, but that's the shape of that polynomial function. So notice that graph has 3 minimum and maximum points, right? It has a minimum point down here, a local minimum, a local maximum up here, and then another local minimum over there, right? So that's 3 local maximums and minimums, but it's a degree 4, right? It's an x to the fourth power, so 1 less than 4 is 3. So this is the maximum number of minimum and maximum points that this graph could have, right? And as far as the x-intercepts, well, look how many x-intercepts we have. We got 1, 2, 3, 4, right? 4 places where that graph crosses the x-axis, and that is the most x-intercepts we're allowed to have since we have an x to the fourth power. And so another good reason to understand these rules is that if you are using a calculator or if you're using something online to graph a function, you know whether or not you're seeing the whole graph, right? If I know these rules and I know I just graphed an x to the fourth power, I know that this is the whole picture. I see 3 minimums and maximums, I see 4 x-intercepts. I know that there's not going to be any more to this graph that I'm not seeing. Like this graph is not going to continue up here and then have another maximum point and come down and have another x-intercept. I know that that's impossible, so I can stop, playing with my window, and I'm comfortable knowing that I'm looking at the entire graph. Right? So that's another thing that it's important to know these, know these rules for. On the other hand, if I just change the window here real quick, so let me go from, let's say, -3 to 3 instead, and let's see what happens there. All right, so on the other hand, if I graph this function and I'm looking at this picture here where I made the window smaller so I don't really see the whole thing. Well, here I only really see 2 minimum and maximum points. I see a maximum point here, a minimum point there, It looks like maybe that one's going towards another minimum point, but I don't really see it for sure. And I also only see, let's see, 1, 2, maybe 3 x-intercepts. So if I graph this function and that's what I see, I'm not satisfied that I'm looking at the whole thing. I know, well, there might be 4 x-intercepts and I only see 3, so let me make this graph, or let me make this window a little bit bigger just to see if there's something I'm missing. And if you do that, you'll see the graph that we had before, which then you would know that that's the complete graph of the function, right? You're seeing all the things that you need to see. All right, so a couple basic rules based on the degree of the polynomial. That determines the maximum number of extreme points and x-intercepts that you can have. Important things to keep in mind as you are drawing graphs of polynomials. And again, if you didn't look at the other videos that I did about graphing polynomial functions, you might want to check all those out to get a complete picture of how to graph polynomials.